Ad hoc cloning means any non-standard method of constructing DNAs. There are no constraints on the methodologies employed, and these approaches make full use of the catalog of available enzymes and techniques to perform a cloning experiment. The other methodologies we'll discuss correspond to standardized methods of fabrication. Though ad hoc cloning would be difficult both computationally and physically to automate, automation is not the catch-all scenario solution to DNA manipulations. For example, various library generation methods are best implemented using ad hoc methods. Additionally, until the price of commercial DNA fabrication comes down one more order of magnitude, there will be some motivation to use these methods in the wet lab in contexts where the change to a sequence is fairly simple. The primary reason you should understand ad hoc cloning strategies is that prior to 2000, there were no standardized fabrication methods, and all published work is some sort of ad hoc strategy. Here we see an example ad hoc method. First, they take a plasmid called p-display, cut it with XMA1 and SAL1, and isolate the larger of the two resulting DNAs. They similarly digest PEGFP-C1 with the enzymes AGE1 and SAL1. They then combine the two fragments into a new plasmid. That plasmid is then used as template for PCR to introduce NHE1 and KPN1 restriction sites, which are inserted into PEGFP-C1 DNA that has been digested with NHE1 and KPN1. The resulting construct is called PNG. This text I just described is the sort of language you will often find in papers, and occasionally it will be drawn out as a diagram like the one shown. The sequence of the product is knowable based on the series of manipulations performed and the sequence of the original plasmids. It just takes some careful analysis to simulate what they are doing and predict the desired product.